Hello, folks. This is for Matthew Eli Josie, I think, is who we're recording for. We're doing a little bit in 8.3. 8.3 is very, very, very similar to 8.1 and 8.2, except instead of doing a proportion, you're doing a mean. What does mean mean? What two variables do we use for mean? Mu and x bar. Okay, which one is which?
X bar is the sample.
X bar is the sample. So when they say of the 81 seniors tested, they scored an average of a 22. That's X bar, right? Mu is the population. Just so you know, the population is always the one that goes in the H naught and H1. It's always the one that is the claim. So when they say to test the claim that the average is blah blah blah, that's mu. That's what you put in your H naught and H1, right? Okay? That's what goes here. Then they'll talk about the sample and they'll talk about of the N number of people tested, here's your sample average, okay? Just like with the last one, we had a value for a test statistic, and here is the formula for it. T equals X bar goes here. They call it mu sub X bar. Don't worry about the sub X bar. Just call it mu. Whatever. Just call it mu. Yeah, mu based off of the sample, whatever. Yes, I am. Yeah. I just started. S is the standard deviation. N is the N. This formula should look kind of familiar. Just like before, if N is greater than 30, we use the Z chart. If N is less than or equal to 30, we use the T chart. Now, one other little bit of information. We solved the proportion in 8.1 and 8.2. We had 3 methods of solving and doing the hypothesis testing. They were the p-value method. They were p-value method where you have a chart and we go 0 to 100% and all the stuff. That was p-value method. We have critical value method where you have 0 living in the middle. And you have like your 1.96 and all the things, right? That's critical value method. Or we have confidence interval method.
You have to do those again? All of them? Wait, I thought you said there wasn't a p-value.
Yeah, I'm gonna get to that. Confidence interval method for P was this is less than this, right? So we did P hat minus the error. We did P hat plus the error, all that thing, right? That's what we did in the last section. You can do the p-value method for mean, but we do not, because the number that you look up, you have to use like technology to look it up in order to get the correct p-value. So we don't do p-value for mean. Yeah. You have to look it up with technology, and I just skip over it. So we don't do p-value method. We only do critical value method. We do confidence interval method. It's just that confidence interval method. What variable goes in the middle for mean? Mu, and it is X bar minus the error and X bar plus the error. That's it. Okay? So we can do critical value method. We can do confidence interval method. What?
We assume that X bar is the beginning. Never mind.
Okay. All right.
It's not that you realize. It's not. Yeah. Keep going.
That's why I keep getting phone calls. I'm like, why is this number from Grand Island called me like 100 times? Like,
Well, I keep getting like spam.
they're doing a tornado drill at CCC. So I get a phone call from CCC, and then I get a phone call from CCC in Grand Island. And then I get a text message from each one. So like my phone's going off like crazy, whatever. Okay. All right, here we go. So let's do.
People don't text you all the time and call you Colin.
What?
Every time, like, I signed up for Remind, and they gave me a name, Colin. Now I just have like those random loan payment things. So,
Oh, okay. Interesting.
they're always saying, hello, Colin. Do you
Alright.
need a loan? And I'm just like, hi, Colin. Oh my gosh, it's so good.
Oh my.
Please don't.
Oh my.
I won't answer to you.
Okay, so example 1, they say p-value method with technology. We're not going to do p-value method. We're going to change that, and we're going to go to the critical value method. Okay, we're only going to do this critical value method style. Oh, they have without technology on example 2, but you can't do every one of them without technology, so we just skip the technology part. Okay, all right. National Health and Nutrition Examination Study, and we are talking about what? Oh, obtain times of sleep Oh, this is interesting. These are the number of hours of sleep. So, out of their people, how many people did they survey, by the way? 12. 12 people. You can count the numbers, or they say 12, right? 12 people that they surveyed. This person gets an average of 4 hours of sleep per night. This one gets 8 hours. This one gets 4 hours. 4 hours, 8 hours, 6 hours, 9 hours, 7 hours, 7 hours, 10 hours, 7 hours, 8 hours. Do we see what these numbers represent? Where are you? 7? 8? I need like 10. I could sleep 10 hours every night if I could.
That would be nice.
Did you know that it is a thing that women require more sleep than men?
Yes.
Did you know that?
Oh,
But we
Why
more
is
sleep
that?
then?
No. Do we get more sleep than men? No. Do you know why? Regardless of whether you have children or not, your brains are genetically wired so that you sleep, women,
Lighter?
you sleep 90% conscious all night long.
Yes. I would imagine.
Only 10% of your brain shuts down, women. Only 10% of your brain shuts down while you sleep. The reason why? Because you have to be able to wake up to hear babies when babies are crying. That's a genetic thing about women. Okay? Do you want to know how much of a man's brain shuts down when they sleep?
Oh, 75.
70%. 70% of a man's brain, look it up. This is actual data. 70% of a man's brain shuts down while they sleep. Only 10% of a woman's brain shuts down while they sleep. So men are getting sounder sleep. It is statistically proven. What?
How does that relate to like deep sleep? You know, like people wake up really easily. You know?
I think that's based off of deep sleep. So in deep sleep, women still only have 10% brain shutdown. Yeah.
I feel like probably need to sleep more like.
Go to bed earlier then.
Well, here's the
I don't know.
thing. If I can't,
Right.
I don't wake up my alarms.
I don't know. Okay, so this is what we have going on. We have 12 people to test our theory and stuff here. They have done this for us. They will not always do this for us. We have to do this sometimes. Do you know, if you had this data, do you know how to take the average? Yes. Do you know how to plug it in and do standard deviation? Yes? Okay, they're giving this to us, right? They say that X bar is 6.8. Let's go 833. We'll just round it off to 3 decimal places, okay? Standard deviation is 1.992. Okay, we'll round it off to 3 decimal places, all right? That's stuff that we need. A common recommendation is that adults should sleep between 7 and 9 hours each night. Use the p-value method. We're not going to do p-value. We're doing critical value method. With a significance level of 0.05 to test the claim. There are the magic words. To test the claim that the mean amount of sleep for adults is less than 7. Okay, so we need our H naught and our H1. In the past, we used P. What variable do we use now? Mu, because that's mean, right? The first one is still always equal to what?
27.
Equal to 7. And the second one is less than 7. To test the claim that the mean amount of times is less than 7 hours. So the claim is the bottom one. We fill this out exactly the same, okay? I'm going to do my bell curve over here. Okay, which tail? The left tail. What percent goes in that left tail? 5%, because that's our fish value, so 5% here. Now, all 5% is going in there. We have kind of like an imaginary 5% over here because we're talking about the middle 90%, right? Now, here's where the difference lies. We've done everything thus far the same except for using mu, right? 90% is what we're going to look up. Which chart?
What's our N? 12?
N is 12. So we look up on the T chart. If N is less than 30, did you write this down? If N is less than or equal to 30, we use the T chart. If it's greater than 30, we use the Z chart. So we're on the T chart. Okay, so we need to look up on the T chart. We need to look up 2 things. One of them is 90% and the other one is degrees of freedom, which is 11.
Okay, but I'm confused
Right?
where we're plugging this in at. Oh, that's our cutoff mark.
That's our cutoff marks for the thing. Yep. Okay, so if you look up at 90% at 11 degrees of freedom, do you know which chart you're looking up? It's the one that's, I think, black and white for most of you. It has the bell curves on the side. It has the bell curves on the side. Flip it over. Yep.
1.79.
Mackenzie, yep. Yep. What is it?
1.796.
1.796. So it would be negative on this side. 1.796. Did you find that? Do we know what we're looking at? 1.796. Cool. Now, the only other thing we need to do is do the formula right here.
You wanna share that with the class?
T equals x bar minus mu over s over the square root of n. So x bar, we said, was the average, which they gave to us, the 6.833 number, minus, what's mu? 7 over s, which is 1.992 over the square root of 12. Okay? Now here's the deal.
You have to put those in parentheses.
According to my data, 6.833 was the average number of hours of sleep for my 12 people, right? Okay? Which is in fact less than 7, right? 6.833 is less than 7. But is it close enough to 7 that it's equal to 7? Because I only surveyed 12 people. I could have surveyed much more, right? So that's what we have to decide, okay? Now, according to this number, what is that number if you do it? Did somebody do it? All right?
Alright.
And where on my bell curve does 0 live?
In the middle.
In the middle, because we're doing critical value method. So like my imaginary guy over here is positive 1.796, right? Where does my test statistic number live? Like he lives like right here, right? So if that's my conclusion, are we saying that it's equal to 7? Or are we saying that it's significantly less than 7? They're saying even though my number is 6.833, that's close enough to 7 that's equal to 7 and not significantly less than 7. So we fail to reject H naught, and our claim is false. It is not less than 7 hours of sleep. It's right about 7 hours of sleep, right? Good? Happy with that?
So it's the same thing, we're just.
It's the same thing.
Different chart.
It's exactly the same thing. You're just looking up in a different chart.
Possibly.
Maybe, possibly. You're only looking it up on the T chart if it's less than 30, right? If it's greater than 30, then you get to use the Z chart the whole time, right? And it's just a different formula that you're plugging in. But everything else stays completely identical. That's what this whole chapter is. Like, you're gonna get tired of this. Okay, good?
Oh, this is the same thing.
All right, let's do, I'm just gonna give you homework. How about that?
Sounds great.
Let's have you do, I don't know, like 1, 2, 3. Can you do 1, 2, 3?
Are they all the same thing? Like all the p-values?
What?
You do the p-values?
You do critical value.
No?
Critical value, critical value, critical value. I am going to probably for the backside have you do like 2 of them. So like 7, 8. Save those and we'll do confidence interval style. And confidence interval style. So everything else will be critical value. If you want to mark those. Like we just did. We haven't done a confidence interval one yet, but we'll do one of those tomorrow, okay? So, I mean, you could do 1 through 6 if you want to. But do at least 1 through 3 if you can, okay?
7 and 8 are the only confidence.
7 and 8 are the only confidence interval style. Yep, we'll do one of those tomorrow so that you can see what that looks like. Or maybe you already know how to do confidence interval. I
Our
don't
X
know.
bar is our mean. Wait, hold on.
I have a question. Can you still look?
There's 2 means that they will give you. The mean that goes with the claim is going to be mu. The mean that goes with the sample is going to be x bar. So wherever they say n equals whatever, and then they'll give you the mean of that, that's x bar. Okay? Questions?
Can you scroll up?
Yeah.
I'm not getting the negative.
0.29?
Yeah.
Okay, let me come help you. I'm going to shut this off.
Negative